Diagnostic ultrasound is a very good imaging technique for many pathologies. It's safe, it's not using ionizing radiation, it gives real-time images, and it's relatively inexpensive compared to many other imaging techniques. But unfortunately for cancer, it's not so good. The distinction between a cancer and regular tissue doesn't come out very strongly. So what we're doing in our lab is trying to develop an agent which the physician can inject just prior to doing a scan, that will, as it passes through the cancer, will highlight the cancer and show it up very strongly. These agents are called contrast agents, and our lab is devoted to developing these agents. We also realized that once we had made a successful contrast agent that really showed up tumors very nicely, we could load drug into those very same agents. And as they pass through the tumor, we could use the same diagnostic ultrasound to release the drug from the agent and have it directly delivered into the tumor. This has enormous advantages because most cancer drugs are very, very toxic and they have very, very bad side effects. So if we could deliver the drug directly to the tumor, we could then avoid a lot of the systemic effects that regular cancer treatment has. We also realized that we could put specific markers on the outside of these agents that would home in on cancer cells and specifically bind to those cancer cells. And we would then be able to definitely know that there was a tumor present, or that hopefully there was no tumor present. When we've made an agent, we want to see how well it reflects the ultrasound. And we do this by testing what we call the echogenicity in a tank in the lab that's held at 37 degrees, which is the same as body temperature. When we've made our agent, we want to test to see how well it will reflect the ultrasound. We also want to see how well it will release the drug. Here you see John has a sample of our agent, which is actually loaded with doxorubicin, which is a anti-cancer drug, a chemotherapeutic. And he's going to test it to see how well it's reflecting the ultrasound. So he's placing it in the sample holder that's held in a tank that's at 37 degrees, which is the body temperature. And you can see on the oscilloscope that as soon as he adds it to the chamber, we get a strong signal showing that it's reflecting the ultrasound very nicely. You'll also see that the tank, the sample holder in the tank has gone the same color as the doxorubicin. When we're sure we have a really good agent that we've tested in the lab, we then take it and test it in animals which have been implanted with tumors. And we can test how well they image the tumors and how well the drug is released into the tumor to cure the cancer.